Huawei's Urban Rail Cloud solution provides a platform to support metro services. It represents a solid foundation for our innovation while ensuring secure and efficient operations. Centralized management increases resource utilization by 40% and simplifies O&M. As such, we can invest more resources and energy into service innovation, allowing Hohhot Metro to achieve the best management quality. We are striving to build Hohhot Metro into a digital benchmark for the industry. The Urban Rail Cloud for Hohhot Metro supports production businesses, as well as internal and external services. Each service has specific requirements, for example, needing different levels of resource security. Therefore, implementation can be challenging. During project delivery processes, such as design, verification, and implementation, we held multiple on-site meetings for industry experts to discuss and refine the solutions. We also performed strict testing on a test platform established by Horinger, ensuring stable and compliant services on the cloud platform. The process showcased Huawei's leading technical capabilities in urban rail cloud delivery, positioning the project as a reference point for other such projects in the industry. In 2013, Zhengzhou Metro and Huawei started building the world's first LTE-based urban rail line. Since then, joint efforts in metro digitalization have been made by the two parties. On May 20th, 2019, Zhengzhou Metro opened Line 5 and simultaneously launched the AFC Network Control Center. Based on Huawei's Urban Rail Cloud, the ANCC works in sync with the Zhengzhou LV Chongtong bus cards and all-in-one cards issued by the Ministry of Transport. Passengers enjoy a convenient travel experience by scanning QR codes to enter and exit metro station. At the same time, Huawei's solution provides robust capacity for expansion and upgrade. In the future, Zhengzhou Metro plans on expanding to 21 metro lines with the capacity to serve 18 million passengers and 45 million transactions. Huawei's Urban Rail Cloud solution centrally manages computing, network storage, and security on the NOCC cloud platform, increasing resource utilization by 30%. The solution leverages virtualization technologies to merge multiple physical networks into one. It also reduces the number of devices and facilitates more efficient O&M. The NOCC cloud platform converges service data and provides platform support for smart metro service application. On May 20th, 2019, Shenzhen Metro and Huawei launched the world's first 5G fixed-point video backhaul project. Now, it takes only 150 seconds to download all the train data. Before, it would have taken at least 1 hour. Huawei's solution increases the data transmission rate from 4 megabits per second to 1.5 gigabits per second. The wireless train-to-ground data transfer relies only on resumable transfer and does not require manual intervention. This has expanded data analysis capability and offered infinite possibilities for image analysis. Huawei's Urban Rail Cloud solution integrates cloud, big data, video, 5G, and other ICT to build a secure, efficient, and innovative cloud platform on the multi-rail line network, facilitating the co-construction of smart urban rails. Huawei has carried out joint innovation with leading design institutes and integrators, and set up a digital urban rail ecosystem lab. To date, Huawei has done interconnection verification tests with over 40 integrators in the industry. Huawei has also participated in the formulation of urban rail informatization standards, led by CAMET, and led multiple teams in the standardization of urban rail clouds in China. In the future, Huawei will continue to enable smart urban rail and work with partners to accelerate its development. Smart urban rail, growing with the cloud. Urban rail's power transportation and development of a city. Urban rail's power transportation and development of a city. Today, ICT is the driving force behind the growth of urban rail transit that offers safer mobility, more efficient operations, and improved services. Huawei is currently the only solution provider in the transportation industry that can both integrate new ICT such as cloud, AI, IoT, big data, ICP, video and GIS technologies, as well as streamlined clouds, pipes, and devices. Huawei is continuously promoting wider ICT application in the industry. Huawei's Urban Rail Cloud solution provides a platform to support metro services. It represents a solid foundation for our innovation while ensuring secure and efficient operations. Centralized management increases resource utilization by 40% and simplifies O&M. As such, we can invest more resources and energy into service innovation, allowing Hohhot Metro to achieve the best management quality. We are striving to build a Hohhot Metro into a digital benchmark for the industry. The Urban Rail Cloud for Hohhot Metro supports production businesses, as well as internal and external services. Each service has specific requirements, for example, needing different levels of resource security. Therefore, implementation can be challenging. During project delivery processes, such as design, verification, and implementation, we held multiple on-site meetings for industry experts to discuss and refine the solutions. We also performed strict testing on a test platform established by Horinger, ensuring stable and compliant services on the cloud platform. The process showcased Huawei's leading technical capabilities in urban rail cloud delivery, positioning the project as a reference point for other such projects in the industry. In 2013, Zhengzhou Metro and Huawei started building the world's first LTE-based urban rail line. Since then, joint efforts in metro digitalization have been made by the two parties. On May 20th, 2019, Zhengzhou Metro opened Line 5 and simultaneously launched the AFC Network Control Center. Based on Huawei's Urban Rail Cloud, the ANCC works in sync with the Zhengzhou LV Chongtong bus cards and all-in-one cards issued by the Ministry of Transport. Passengers enjoy a convenient travel experience by scanning QR codes to enter and exit metro station. At the same time, Huawei's solution provides robust capacity for expansion and upgrade. In the future, Zhengzhou Metro plans on expanding to 21 metro lines with the capacity to serve 18 million passengers and 45 million transactions. Huawei's Urban Rail Cloud solution centrally manages computing, network storage, and security on the NOCC cloud platform, increasing resource utilization by 30%. The solution leverages virtualization technologies to merge multiple physical networks into one. It also reduces the number of devices and facilitates more efficient O&M. The NOCC cloud platform converges service data and provides platform support for smart metro service application. On May 20th, 2019, Shenzhen Metro and Huawei launched the world's first 5G fixed-point video backhaul project. Now, it takes only 150 seconds to download all the train data. Before, it would have taken at least 1 hour. Huawei's solution increases the data transmission rate from 4 megabits per second to 1.5 gigabits per second. The wireless train-to-ground data transfer relies only on resumable transfer. and does not require manual intervention. This has expanded data analysis capability and offered infinite possibilities for image analysis. Huawei's Urban Rail Cloud solution integrates cloud, big data, video, 5G, and other ICT to build a secure, efficient, and innovative cloud platform on the multi-rail line network, facilitating the co-construction of smart urban rails. Huawei has carried out joint innovation with leading design institutes and integrators, and set up a digital urban rail ecosystem lab. To date, Huawei has done interconnection verification tests with over 40 integrators in the industry. Huawei has also participated in the formulation of urban rail informatization standards, led by CAMET, and led multiple teams in the standardization of urban rail clouds in China. In the future, Huawei will continue to enable smart urban rail and work with partners to accelerate its development. Smart urban rail, growing with the cloud. Urban rail's power transportation and development of a city. Today, ICT is the driving force behind the growth of urban rail transit that offers safer mobility, more efficient operations, and improved services. Huawei is currently the only solution provider in the transportation industry that can both integrate new ICT such as cloud, AI, IoT, big data, ICP, video and GIS technologies, as well as streamlined clouds, pipes, and devices. Huawei is continuously promoting wider ICT application in the industry. Huawei's Urban Rail Cloud solution provides a platform to support metro services. It represents a solid foundation for our innovation while ensuring secure and efficient operations. Centralized management increases resource utilization by 40% and simplifies O&M. As such, we can invest more resources and energy into service innovation, allowing Hohhot Metro to achieve the best management quality. We are striving to build a Hohhot Metro into a digital benchmark for the industry. The Urban Rail Cloud for Hohhot Metro supports production businesses, as well as internal and external services. Each service has specific requirements, for example, needing different levels of resource security. Therefore, implementation can be challenging. During project delivery processes, such as design, verification, and implementation, we held multiple on-site meetings for industry experts to discuss and refine the solutions. We also performed strict testing on a test platform established by Horinger, ensuring stable and compliant services on the cloud platform. The process showcased Huawei's leading technical capabilities in urban rail cloud delivery, positioning the project as a reference point for other such projects in the industry. In 2013, Zhengzhou Metro and Huawei started building the world's first LTE-based urban rail line. Since then, joint efforts in metro digitalization have been made by the two parties. On May 20th, 2019, Zhengzhou Metro opened Line 5 and simultaneously launched the AFC Network Control Center. Based on Huawei's Urban Rail Cloud, the ANCC works in sync with the Zhengzhou LV Chongtong bus cards and all-in-one cards issued by the Ministry of Transport. Passengers enjoy a convenient travel experience by scanning QR codes to enter and exit metro station. At the same time, Huawei's solution provides robust capacity for expansion and upgrade. In the future, Zhengzhou Metro plans on expanding to 21 metro lines with the capacity to serve 18 million passengers and 45 million transactions. Huawei's Urban Rail Cloud solution centrally manages computing, network storage, and security on the NOCC cloud platform, increasing resource utilization by 30%. The solution leverages virtualization technologies to merge multiple physical networks into one. It also reduces the number of devices and facilitates more efficient O&M. The NOCC cloud platform converges service data and provides platform support for smart metro service application. On May 20th, 2019,
Hi everyone, please have a seat. We will be starting in 5 minutes.
Project. Now, it takes only 150 seconds to download all the train data. Before, it would have taken at least 1 hour. Huawei's solution increases the data transmission rate from 4 megabits per second to 1.5 gigabits per second. The wireless train-to-ground data transfer relies only on resumable transfer and does not require manual intervention. This has expanded data analysis capability and offered infinite possibilities for image analysis. Huawei's Urban Rail Cloud solution integrates cloud, big data, video, 5G, and other ICT to build a secure, efficient, and innovative cloud platform on the multi-rail line network, facilitating the co-construction of smart urban rails. Huawei has carried out joint innovation with leading design institutes and integrators, and set up a digital urban rail ecosystem lab. To date, Huawei has done interconnection verification tests with over 40 integrators in the industry. Huawei has also participated in the formulation of urban rail informatization standards, led by CAMET, and led multiple teams in the standardization of urban rail clouds in China. In the future, Huawei will continue to enable smart urban rail and work with partners to accelerate its development. Smart urban rail, growing with the cloud. Urban rail's power transportation and development of a city. Today, ICT is the driving force behind the growth of urban rail transit that offers safer mobility, more efficient operations, and improved services. Huawei is currently the only solution provider in the transportation industry that can both integrate new ICT such as cloud, AI, IoT, big data, ICP, video and GIS technologies, as well as streamlined clouds, pipes, and devices.
Hi everyone, thank you for joining us today for the 9th Huawei Global Rail Summit. In today's summit, we will have several distinguished speakers that will exchange ideas on the trends and challenges of digital rail transformation, as well as exploring the future of our mobility. Among our distinguished speakers, we will have Monsieur François Daven, General Director of UIC, Mr. Jeffrey Sim, CEO of SBS Transit Rail Business, and Mr. Stephen Chong, CTO of Rail Industry in Huawei EBG, Mr. Vincenzo Bloise, International Sales Director at Almaviva, and Mrs. Franchini that will support him on this speech, and Mr. Li Jie, President of Huawei Enterprise Wireless Domain. And at the end, we will have the launch ceremony of Huawei FRMCS solution. So let's start our 9th Huawei Global Rail Summit, and let's welcome on stage for the opening speech, Mr. Shangxi, the Vice President of Huawei Aviation and Rail Business Unit.
Hello, good afternoon, everyone. It's so good to see all of you again after 4 years at Huawei 9th Global Rail Summit here in Berlin. It has been an honor for me to have this opening because that, as you know, a lot of things have changed in the past 4 years, but the railway industry remains the hotspot for investment and a key driver for the green, smart, passenger-friendly public transportation and world economy. And Huawei remains an industry needing ICT solutions with much offering for this industry, as you can see at our booth. So I would thank all of you for coming, and also I will thank all your support and trust in the past years. Because of that in 2021, Huawei global revenue has reached $99.9 billion with the solid financial figures. And Huawei, as an ICT solution provider and digital information enabler for railway industry, we have served railway industry for more than 20 years. So we have left our footprint on more than 130,000 kilometers of railway for more than 50 global railway operators, and also 300 urban rail lines for more than 70 cities. With all this experience, Huawei has accumulated deep understanding of railway industry, and we showcased the capability to use the latest technology like 5G, AI, big data to enable our solution partners to serve the railway and metro operators better. Now, we can clearly define our mission in the railway industry, that is, reshape connectivity, reconstruct platform, and enable intelligence. Reshape connectivity with the latest diversified technology, wired and wireless. As you can see at our booth, the FRMCS, Wi-Fi 6, twin-to-ground wireless communication, all optical network, integrate IP network, and for the smart station campus network, and also including the integrated energy solutions. With all these connectivity technologies, we can better serve the upper level platform. So we are honored to have Mr. Li Jie today, our President of Enterprise Wireless R&D, to officially launch FRMCS today. And also to reconstruct the platform. As you can see, we can have a cloud-based digital platform which can bring all the data together and all the capability in one unified platform, including AI, big data, voice, communication, and so on. So we can break barriers between different siloed IT systems and create more synergies there. Besides that, I think what we are doing today is then to enable the intelligence with all the connectivity and platform together with our partners, so we can create more smart solutions during construction, daily operation, and also for the predictive maintenance. So that's what we are doing today. That we also have Stephen Xiong, our CTO for railway industry. He will give you more about how Huawei can drive digitalization in future rail and create value together. Create value together, that's what we are doing today here. So we also have the distinguished speakers from USA, from Singapore SBS Transit, and also from our solution partner, Almaviva. So together, we share our views and practices. And so tomorrow, we can move on this new journey called the digital transformation. So I hope you all enjoy this journey. Thank you.
Thank you, Mr. Shangxi, for this opening speech. Now, who's better than UIC, the International Union of Railways, to pave the road of the future of our mobility? And who's better than Mr. François Daven, the General Director of UIC, to help us better understand the trends and practices of digitalization in railway? So please welcome with me on stage, Mr. François Daven, UIC General Director.
Okay, so thank you very much for giving me the floor today. I will try to be rather concise because I see the program and I think you will have a lot of exciting technical demonstration. Perhaps I will try to explain in a few words what UIC is. First of all, I would like to say that UIC is in a way quite an old lady because we have been founded in 1922, so this year is our centenary. And well, UIC is known by its leaflets, so the UIC leaflets, well, we have made basically the whole braking system for the railway. We have been standardizing a lot of things, operationally speaking. Well, the wagons, the gauge, the famous UIC gauge that some people call the standard gauge. And perhaps you would be a little bit astonished to see, well, that the old lady is speaking about telecommunication. Why? Well, for quite a simple reason. Is that because in the beginning of year 2000, it was at UIC that we made actually the specification for GSMR. So the GSMR that I think a lot of companies are using worldwide. Well, in Europe, I think there is more than 200,000 kilometers equipped in Europe, and I think more than that are outside Europe. That's a specification that had been made by UIC. Actually, we have the intellectual property right of GSMR, because, well, our engineers, when I say our engineers, that's the engineer of our members that have been collaborating together to draw this specification. And, well, I think GSMR was a success story for some quite basic reason. First of all, it was made by the community of the rail operator, meaning that in the process of the definition, the aim was the operation. And it was made by people who understood the operation. The second thing is that since the inception of GSMR, we wanted to make it global. That means that with GSMR, we have been working with ETSI, and we have been working also with 3GPP to be sure that this system was really globally specified. And in doing so, we have been also very keen, and it was thanks to European funding, to do thorough testing. That means that we had a project that we were called EREN in the year 2000 to really test GSMR in real condition with actual high-speed train at 300 kilometers per hour, and to be sure that indeed it was made for actual testing and operation. So that's where I think UIC gained expertise in telecommunication, and now obviously we are close to the end of GSMR because, well, you all know that GSMR is 2G, basically, so it was the infancy of the digital mobile telecommunication. You all know that, for instance, with the GSMR, the maximum throughput is 32 kilobits per second, so at our times, it may seem ridiculous. So we had to evolve. And that's the reason why, since, well, a little bit less than 10 years, we are working on the next generation. And for the next generation, we decided to jump to 5G. And that's, well, the acronym that was cited by the speaker before me, FRMCS, Future Rail Mobile Communication System. And that's an acronym that was created in UIC, but more importantly, the specification is made those days in UIC. So I will speak a little bit about how we are doing it, why we are doing it, and what could be the expectations for the future of operation of FRMCS. So how are we doing it? I think what is important here is indeed to say that it's also a commitment from mainly European railway to work together on defining those specifications, and a proof of confidence into UIC because they decided to hire engineers to work on this specification. Second proof of confidence, that's also the fact that we have quite a few contracts, mainly with European institutions, to develop this new generation. So that's what we are doing. We are doing that in a very open way because it's made in close cooperation with ETSI at the European level and with 3GPP at the global level. Like I said, with GSMR, we do really want that FRMCS, at the end of the day, is actually a telecom standard, even if we are doing it. Also, as a proof of this confidence on the how aspect, we are developing into a consortium, we are coordinating a consortium with European manufacturers and European operators to have the first demonstrator for 5G, at least in Europe, within what we call the 5G rail project that is close to completion. So we are quite happy to see that we have the first things that you can actually see with an actual 5G demonstrator. And well, in the how, there is also the question of frequency, and I know that's also a global concern because this meeting is obviously global. In Europe, there are specific bandwidths that are reserved for FRMCS, like it was the case for GSMR. There again, it was some kind of struggle because we have to convince the carriers that it was wise to give some megahertz to the railway sector. Well, you know the price of megahertz, so it was not an easy task. But at the end of the day, we made our case. So we have, I think, 2 bandwidths of 10 megahertz, if I'm not confused, that are reserved for FRMCS. And at the end of the day, that one of the key features for the safety of the whole system. Then I will go to the why. Why are we going into defining FRMCS? Because after all, GSMR is working, and there are still some contracts for GSMR. Well, basically, because the manufacturers will no longer support 2G. So around 2030, that would not be possible to have, again, equipment for 2G, so it was necessary to change. It was also necessary because it was said, and I will not enter too much into that, we need to digitalize the rail system, and it's not possible to digitalize the rail system if we have not a telecommunication backbone and a radio telecommunication backbone, because we will need to retrieve and to use a huge amount of data, whether we are speaking about ATO or predictive maintenance or all the fancy ticketing features that we want to implement. We will need those data, and on top of that, it will need to be real time, because one of the main challenges that we have for our sector, out of the telecommunication questions, that really to be able to increase the capacity of our system in investing, obviously, in new infrastructure, but minimizing the need to invest on infrastructure. And all the studies show that if we are mastering the digitalization process, we can increase the capacity of the existing infrastructure by, we think, about 30%. So that's a huge, I think, societal and also economical subject, what we are doing now together into the FRMCS ecosystem. And in UIC, we are global, and I would like perhaps to insist on that. Since 1922, UIC is global. Since the inception, we had, at the time, the Soviet Union. We had also China very soon within UIC. We had a lot of African countries. We had a lot of countries in the Middle East. And we still have. We are today working, well, this morning I was with the Institute of Research of Korea, the name I don't remember, and my next appointment was with Saudi Arabian Railways. So we are really talking to the world, and I think that for FRMCS, our new specification, that will be really absolutely key, that we are turning it into a global product. As I said, I explained the how and the why, and the fact that we had the support and the confidence of the European ecosystem to produce that, because after all, UIC is based in Paris, and to say the truth, the working groups that are producing the specification are European working groups, but we really want to have an open system, and that will be the end of, the last point of my presentation is what have we ahead for the implementation of FRMCS. Well, I think what will be really important, first of all, that will be to be able to make the field testing. And that's something we are advocating at the European level. We hope to have the financial means, and our members hope to have that, really, because we do think, and perhaps I don't have the time to just describe what we did for GSMR, but that's really one of the key reasons why GSMR was a success. Because it was easy to implement, because all the testing have been made. So when we released the GSMR, we already more or less solved all the implementation issues. And I think that for FRMCS, we have to do the same. It's not little money. This money will not obviously goes to UIC, but to the community of the railways to do the test. That costs money to do tests at high speed, for instance. We are speaking roughly of about 50 million euro, but really we need to do this testing. Well, we all know ERTMS. We all know that there are some difficulties. We don't want to have the same kind of questions with FRMCS. Why? Because it will be the data backbone. And we need the data backbone for all the new implementation. And obviously, that will be perhaps the first point that I would like to insist on the future implementation. As GSMR was mandatory for the European Railway Traffic Management System, ERTMS, so as you know, ERTMS, it's a technical specification for interoperability. This specification has two annexes. One is on control command system, not UIC. The second one is GSMR. So starting the end of this year, you will have a new annex that will be FRMCS, and that will be made to exist with ERTMS. That means that a new version of ERTMS, not implemented tomorrow, it would not start in 2023. We think that the first commercial version of FRMCS on ERTMS, that will be 2025, 2026, but that's a near future. The new version of ERTMS will be mandatory with FRMCS. So that's a huge development, both for railways and for the industry. But obviously, as it was the case with GSMR, a lot of different control command systems are equipped with GSMR. And that will be the same with FRMCS. FRMCS will have a life of its own, I should say, where railways all around the world, and as the case may be, some public transport system will use FRMCS. So we need to work together at the regional and global level. As I actually didn't say it, in UIC we have different regions. So we have a core business, which is indeed in Paris, HQ, UIC HQ with all our working groups, but we have a region in Asia Pacific, Middle East, Africa, South America, and North America. And for all this region, I think, having in mind that it will be very powerful tool for implementing digitalization of our railways, we will have to work on use cases. There will be obviously European use cases. Well, ERTMS will be one of them. There will be use cases on ATO because that will be very difficult to do automated train operation without having some, for instance, video. And if you want to have video, you need to have 5G. Well, there will be use cases everywhere for predictive maintenance. There will be also use cases for something everybody is speaking about, meaning the digital twins. The digital twins for maintenance to know how your rolling stock are evolving, but also digital twins that, as the case may be, can be used for improving the traffic management. At some point, you will have to model the whole system and to find ways to optimize your traffic management. And for that, you will need real time. You will also need somehow real time to succeed into the interconnection between the railway system and the public transport system. You will need to adapt more and more to this reality that, well, and that's something really important for UIC, then that's perhaps the old lady dress, that that's a fundamental of our sector. We need to attract more people to rail and public transport. That's the fundamental. Here, I have been speaking about fancy thing. Well, I'm an engineer. I think there is a lot of engineers around the table. We love those complex things, but at the end of the day, what we have to deliver, it's an ecosystem that will be friendly for the end user, for the customer. Make things as simple as possible. And for making things as simple as possible, in the world that is ours, we will need to process a huge amount of data to make things easy for our customers. So in UIC, we issued a few months ago what we call a manifesto, which is a vision of what should be the interconnection between railways and public transport for making the life easy for our fellow citizens. Well, I think you have all been hearing to political and less political speech that we are entering in a time where energy price and scarcity will be critical. We're also entering in a time where global warming has been something which is quite obvious for everybody. So we need to spare energy, we need to be frugal, we need to optimize. And I do think that FRMCS, if we think a little bit out of the box, is really the way to optimize our system. And I really hope that due to the work we did in developing those specifications, we will be able together to develop those use cases. And from UIC perspective, well, obviously, it is starting in Europe, but we really need to work on those use cases and to be sure that we can learn from the whole world how to have the best solutions. That's something I would like to finish my speech on. UIC is about collaboration, mutualization, getting the good ideas from all the railway operators or also manufacturers. Well, manufacturers, you cannot be member, but you are invited if you are interested to participate to our working groups. But we need all the good ideas. And I think that FRMCS, that will be really a tool around those use cases that will get into the substance of the service we have delivered together, all the together, well, difficult for French, all the good ideas that we can find. Thank you very much.
Thank you, Monsieur Daven. As we can see, FRMCS will be a real game changer. So now let's see how SBS Transit, the leading bus and rail operator in Singapore, is able to carry every day millions of passengers on their extensive bus and rail network while ensuring the best operational efficiency and safety in addition to the best passenger experience. So please welcome with me on stage Mr. Jeffrey Sim, the CEO of SBS Transit Rail Business.
Very good afternoon to all. Thanks to Huawei for inviting me here to share our experiences in Singapore and how we became one of the world's leading rail operators. First and foremost, let me introduce myself. I run SBS Transit Rail Business. We operate 3 lines in Singapore. I'll share that with you later. At the same time, I also have a dual role where I'm involved in business development of ComfortDelGro. ComfortDelGro, as some of you may know, it's a world-leading land transport company with a footprint in 8 countries. And recently, we have won the rights to operate and maintain the Auckland Rail franchise, consisting of 95 kilometers in Auckland. And we have also bidded and is in the top 2 for the Western Sydney Airport tender that will connect the new Western Sydney Airport to other parts of Australia, in Western Australia. And we are also in the top 3 for the Grand Paris Express, collaborating with RATP DEF and Alstom in that tender. And we have huge ambition to grow our footprint beyond Singapore and beyond Auckland. So I'm very happy to be here with you. I hope in the next 20 minutes I will be able to share with you how we've managed to transform SBS Transit to be where we are today. This is the scope for my presentation. I'll share first with you the lines that we operate and how we have improved reliability, specifically using technology, and our approach to how we adopt technology, not just within the rail industry, but across the industries around the world. And the technologies that we are using today, but importantly, what are the technologies that we're exploring going forward, and Huawei plays a very important part in this as our technology partner. So we operate 30% of the rail network in Singapore. Today, our rail network is 250 kilometers. We will expand to 360 kilometers in 10 years' time. We opened the Northeast Line, NEL, on 20th June 2003. A very interesting fact, which is not known to many, is that the Northeast Line is actually the world's first fully automated heavy rail, which makes us the most experienced GA4 operator in the world. We have coming up to 20 years of experience. And that line is 20 kilometers, 16 stations, and there's network expansion as I speak. And it's of Alstom trains with annual mileage about 4 million kilometers. The SP LRT is a Singapore LRT. It is a light rail system that fits into the Northeast Line. In fact, this line made our foray into the rail industry. It was opened in 2003. And of more recent times is our downtown line, which currently is the longest line underground GA4 network in Singapore. And that is for 42 kilometers. So these are the rail networks that we operate in Singapore. What is very interesting and what is something that we are very proud of, it's rail reliability. For some of you who may be familiar, we use the MKBF, or what MKBF stands for is mean kilometers between a failure of more than 5 minutes. It is the most difficult and challenging measure of reliability that's used by operators around the world, because imagine, it's the kilometers you need to travel before a delay of 5 minutes. And I think since my speech till now, it's probably about 5 minutes. That's how quick 5 minutes is. We are very happy to share with you that in Singapore, we have a target of 1 million MKBF, which means that the network needs to travel 1 million kilometers and more before 5 minutes delay. And the Northeast Line was the first in Singapore to achieve that target. The Downtown Line is the most reliable line in Singapore for the last few years, and we have both lines achieve more than 4 million. We believe that this puts us up among the top lines in the world. Later I'll share with you how did we manage to realize this achievement. And if you look at the chart that is on the left, you can see that we started out quite modestly in Singapore. It was hovering about 200,000-300,000. And how did we then increase by 20 folds to where we are today? It is not by sheer luck or prayers, I can assure you that, but there's a lot of systematic efforts that were put in place in order for us to achieve this objective, and technology is a key enabler. Now, we also do equally as well for the light rail, and that's shown by the chart on the right. We have improved the light rail performance, which we all know that may not have the same rigor of design, of redundancies and the various technologies, but still we have managed to actually achieve 435,000. To me, that's also a very credible record. So with this painted, you might then be thinking, you know, what are the things that we have done to move us there? Technology is one, but there are other things that I would like to share with you, and perhaps that could be important depending on whether you're an operator or technology solution provider, of how you're going to help networks around the world to achieve such performance. This is where we think it's our differentiator, and it's key to us really achieving very high reliability measured by the MKBF. At the top, it's about having a joint ownership. As we may know, running a real network, you have generally two groups of people, the operators and the engineers. And whenever there's a fault that happens, the engineers will blame the operators will blame the engineers. At the end, whose problem is it? There's no one's problem. But what we have decided to do is to make sure that the KPIs that we set is jointly owned by both operator as well as the engineers. So they know that their fates are intertwined, and they know they need to help each other in order to achieve that target of 1 million MKBF. So they work hand in glove, knowing their fates are tied together. Next, we imbue a curious and innovative mindset among our people. I've always shared with them using the football analogy. I would like us to win 4-2 in a football match, rather to win 1-0. I'd rather that we be a bit more bold, be curious, be innovative, to implement solutions that we may not see success all the time, but at least that gives us an avenue and an opportunity to do well, to do better and improve our outcomes. We have mistakes along the way, but I believe that we have more successes than mistakes and near misses. And by doing that, we have made ourselves a stronger organization. So we imbue in our people at all levels to have a curious, innovative mindset, to harness technologies, to find new ways of doing things better. And that's how we have seen a continuous improvement in our reliability. Next is also equally important is to have cross-specialization structures and processes. If you look at real networks around the world, operators divide their workforce by rolling stock, by signaling, by systems, by power. But that's a very artificial way of dividing groups of people, because the systems don't just fail as a rolling stock or as a systems. In fact, more often than not, it's because of cross-interfaces, of issues, of signals not being sent correctly between the rolling stock and signaling and systems. So we find that it's important that although you have joint ownership at a very top level between operations and engineering, it's equally important to make sure that we have the right structures and also processes that will facilitate people working together in solving the issue and preventing the next critical fault from happening. And of course, all of this, technology as enabler is the building block. If you look at the railway, and I encourage you to visit Singapore if you can, we will show you that the technology that we use is pervasive throughout our organization, not just in terms of productivity, not just in terms as an enabler to do things better, but we've put a suite of technologies into predictive maintenance, in condition monitoring, harnessing data, putting in analytics, both in data and video, and all of this is basically so that we are able to use it as a technology, as leveraging it so that we are able to do our work better. And that you can see in some of the examples I'll show you how we have managed to transform ourselves. This is also a very important chart that basically is a process, our O&M, our operations and maintenance framework. If I bring your attention right to the top under engineering, the engineering people, the engineers' main task is to prevent a delay or disruption. They have to preempt a failure from happening. But we all know, despite best efforts, a fault can and will happen. But when that happens, it's where the operations staff, who are the frontline staff, whether the train drivers or the station staff, they need to focus on expeditious recovery. Because 5 minutes, as we measure it in MKBF, it's a very short time. And why 5 minutes is used is because that's where humans start to get irritated, that the trains are not moving, they're not getting to their destination. And that's why we are focused also a lot in how we're going to recover the trains. We operate Alstom trains, Bombardier trains, Mitsubishi trains, and I was very heartened when Henry, the chairman for Alstom, visited us before, and when we shared with him the suite of design enhancements we have done to his train, he said, "You have made your trains even more reliable when I first delivered your trains to you. Because we don't believe in status quo, we don't believe in accepting the products as it is, and through the engineering rigor and the knowledge that we have of our engineers, we have improved the design of the trains. For example, we have implemented remote resets, so that if there's a fault were to happen at the OCC, they are able to reset the fault. If that's not possible, we will do on-site bypasses. so that if there's a critical fault, you're able to bypass a critical relay, and then the mobile train can then move again. So we have put in place this kind of expeditious recovery means for the purpose of if and when a fault should happen, we're able to quickly rectify it, get the train out of the way, and ensure operations resume. Now, we also know that some of the faults that happen, it's not a short one, it's of a long duration. That's where the psyche of the organization needs to switch into an incident management mode, where the whole objective is to minimize impact to commuters. We have to then decide how best to provide the right information to the commuters so that they can decide what to do next for their next bound of travel. Do they want to take an alternative transportation? Do they want to wait out for the fault to be recovered? Or they just want to do something else in the meantime, for example? So that's where information is key. Through the surveys that we have in Singapore, the commuters aren't really that upset that a fault happens because they know these things do happen. But what they're very upset is that they're not informed of what's happening, that they're lost. So therefore, key during a disruption is to make sure that you have the right information, timely information that's pushed down to the commuters. That's the whole process of incident management for us. And we've gone down to the letter of even making sure that the stations are well informed. You have pull-down charts. We have made sure that our marshallers are well informed. And during these times, we activate the whole organization. It's not just operations or engineering. We activate HR, we activate finance, we activate IT, and we exercise and validate them during normal times to make sure that they, being some appointment holders like in charge of marshalling at certain stations, in charge of bus stops at certain stations, they all get activated, respond within certain time, and quickly recover. It's a whole organization effort. So this is really our simple but a very effective framework to how we have managed to reach very high standards of not just reliability, because ultimately it's the commuters at the heart of all that we do. And our commuters are very satisfied because they know and they're very confident that Best Transit is one where we know that we exist because of them, and we do our best effort to make sure that their journey is a pleasant one. Now, if you look at the right-hand side or the left-hand side of the chart, in our perspective, it's a continuous improvement. We make sure that we learn from every incident. We do a thorough investigation, not just the root cause, but the rest of the causal factors. So at the end of the day, I don't mind if I let in a goal, but I don't want that goal to be repeated in the same manner. So we learn as an organization, and that's where we accept mistakes, but we just make sure mistakes don't happen again. Our approach to leveraging technology, which I shared, is a key enabler. 3 simple things that we have done. We have put in place a structure, and there are dedicated structure and resources for applied technology. If you leave the engineers who is going to mend your fault, attend to your fault, and you ask him to think about technology, where do you think his priorities will be if there's going to be a fault that happens day after day? He has no time and capacity to really look out for technology that we can help to improve the system. So therefore, we have put in place dedicated focus and capacity for our engineers, a group of very dedicated engineers, to look within the rail industry, look at what the other operators are doing, look at technology suppliers within rail and outside of rail, and what can we do to incorporate these technologies that we are able to then harness better outcomes. Next is in terms of a process. You can't just have this structure and leave them as the only catalyst for the organization to look at technology. We need to have ideation and needs identification. That starts first. It's a whole organization approach about thinking what the use cases are, what are the problem statements, what are things that we want to improve, because these are actual needs of the commuters. You need to do a road mapping. You have tons of technology. You need to prioritize which one you want to go first. What are your key needs? You need to identify, to work out the technology roadmap. And we are in no illusion that we have monopoly of ideas or that our people are good enough to implement all of this. We collaborate with partners, technology solutions providers like Huawei. We learn from each other. We attend conferences like InnoTrans. We share. Because ultimately, we believe that through this kind of sharing, we beget more sharing and we have more ideas of how we're going to just make our network even better. And of course, staff development. We teach our people so that they know what are the technologies out there. We expose them to these technologies during seminars, during conferences, And of course, this also helps in terms of overall development of the person and retention, and that's what we aspire to do. So process is equally as important as structures. Now, at the end of the day, we also need to make sure that it's properly governed in terms of how we implement it. We have technology committees at the various levels. We bring in board members who are steeped in their own technologies. We have data analysts who are experts in their fields. We also make sure of late, especially on cybersecurity, because having a technology that brings about and improve our operational outcome by the expense of increasing vulnerability to the system, that needs to be really rationalized these days when you see that there are state, non-state actors out there. They're just waiting to infiltrate systems, whether it's ransomware or not. So of late, we have also incorporated as part of a governance, a cybersecurity standard and compliance. So just to give you a flavor of the kind of technologies that we've put in place. In maintenance, we have incorporated an end-to-end digital maintenance processes. On our network, we have QR codes. The passengers can report defects in trains and stations. We have a depot management system where we automatically assign available rail technicians to affected trains whereby it needs rectification work through the depot management system. All faults are recorded in our rail corrective maintenance system that is web-based. We have recently moved it to app-based because if you look at smartphones, it's being used by many people, all of our staff, and we're leveraging over this for such information to be captured. Now, we imagine with such information that's been captured, you are then able to do trending of the information that you get, and you're able to then preempt deterioration, and that also helps in terms of how, where, and when we want to actually bring in the train. We have also an in-house development for our track access management system. We have also got an app-based hazard incident reporting system where any staff is able to report unsafe conditions. And we have through our apps, they're able to access to all different work instructions. And at the end of it all our staff are now using e-maintenance checklists on tablets. So we have really digitalized the entire end-to-end from fault reporting to fault closure, and in all these different processes to really digitalize it. This improves, obviously, productivity, but importantly, you are able to harness data that we can use for many other purposes. Condition monitoring. We have now moved from a very routine form of maintenance based on time or mileage to condition-based maintenance. We all know as a concept that works. The question then is that what kind of parameters do we need to have in order for us to move into condition-based? And we have harnessed various technologies, as you can see from this slide. Our Northeast line utilizes overhead catenary for power delivery. We have an OCS video monitoring system where we make use of image recognition technology, and we are then able to determine alignment and detect foreign objects. In the past, we have to erect scaffolding, put our people up there and do measurements. Now we put them on board the train. They run many times a day. Over the network, it's more accurate, it's more productive, obviously. And also we're able to incorporate thermography. In the past, during entering hours, when we go and look for such faults, it will never happen because things have already cooled down, right? And therefore now in thermography and on a real-time basis, you are able to spot anomalies and we're able to then intervene early. Integrated supervisory and control system, our SCADA system. Simple things like CPU usage, memory usage, disk usage, because we have problems whereby there's memory overflow and when the systems hang. So we then do condition monitoring to make sure that we monitor the status, and through data and pattern recognition, we know what are the triggers that will give rise to certain of these faults rendering the system immobile. So we have done that as well. Move to point machines. We have also incorporated the condition monitoring for that. We have done partial discharge monitoring for power and online dissolved gas analysis. And for the rolling stock on trains, we have wheel impact load detector, hall exit box. So that's a suite. This is just a flavor of the various technologies that we've incorporated to very good use. Ultimately, I would like to bring your attention to the bottom left. We have pulled all this information from condition monitoring together with the alarm system that is provided from the rolling stock as well as systems manufacturer. And we pull this data, we apply analytics so that we're able to preempt faults, and all these get aggregated at the Integrated Maintenance and Diagnostics Center, which we have created to be next to the OCC. So now the traffic controllers are not just monitoring the network. We have engineering staff that is within the IMDC. They are looking out for potential faults to happen. Their main role is, how am I going to preempt a critical fault from happening? And sometimes you are just given seconds and minutes to make that kind of decisions. And we have actually preempted some faults from developing into critical ones that will render the whole system immobile. So this is, I think, important for us as far as the technology, not just in productivity, but as you can see, it's about preemption, which will improve reliability. Of late, we have also harnessed data and video analytics. We have built an in-house data analytics center of excellence. We have hired data analysts, data scientists, because we need to understand data. In fact, some may think that you do not have sufficient data, and our experience is that we have more data than we need. The issue is that we are not really harnessing the power because we're not understanding what the data signifies. So we've got a simple project which we call Project Foresight. Now, we operate Alstom trains and Alstom signaling system. You might be quite surprised to know that the two logs of the rolling stock and signaling are not synchronized. That makes troubleshooting very difficult. And therefore, through our own development, we have made sure that they are synchronized. Now, we have done one step further. Logs are typically used for troubleshooting. Now, imagine if your logs is able to be produced on a real-time basis with thresholds and with patterns, you may be able to preempt a fault from happening. For example, a train may go into an emergency braking whenever there's 10 cycles of loss between the train and trackside signaling. If you're able to preempt that at 6 cycles, and if your experience show you that whenever a train goes into 6 cycles, inevitably, within a certain period of time, it will be at say, maybe an hour later, that is a very important information because you are then able to intervene and preempt. Next, we have also moved into video analytics. We are working with other solution providers where you're able to spot anomalous crowding, you're able to spot unattended baggage, and of course, non-mask wearing. Well, in Singapore, we're quite particular about wearing masks for public transport, so we're able to spot people who are not wearing masks. We're also able to use video analytics to move into customer experience enhancing initiatives. Imagine if you're able to spot someone on a wheelchair before it enters the station, at the outside of the station. If someone that is on crutches, you are then able to swing your station staff to assist the person early on, right? So these are all the different kind of customer enhancing initiatives that we can put in place with video analytics. And next is also in terms of the track intrusion detection system. In our LRT system, we can see, oh, thank you very much. Thank you. This is appreciated. I actually lost my voice because of the conference. I just hope I'm halfway through, and I think my voice should be able to last me all the way. If not, I've got a backup. A backup is somewhere there just waiting to take over me. So track intrusion detection is that we are able to make use of technology to improve security outcomes. If there is an object, it spots and tells the traffic controller. If somebody will intrude, it tells it. So you can see that this kind of technologies just make sure that our railway is safer and more reliable. And of course, going forward in the future, what are the new technologies that we're exploring? This gives you a glimpse. We are now working with Huawei to see how can we use smart glasses to enable remote assist. Imagine that if you have a train driver that is faced with an immobile train. Yes, you can train him as best as you can, but what happens if it's not competent enough? The train will have a very long, prolonged delay. But imagine if you have the whole OCC and engineering experts that's able to assist him as he encountered that problem. They are able to see what he is saying up front. They are able to then push information to him for him to do his recovery best. And that's what smart glasses allow us to do. And imagine if you can use smart glasses, couple it with augmented reality. As he were to go to certain cabinets to reset certain circuit breakers, he knows exactly which one to do, which circuit breaker to actually focus. And therefore, you are able to then have the whole competency of the organization push forward and assist your frontline staff. So that's what we're trying to work through remote assist. And it's also the same principle for remote training, so that you don't need to have one trainer on site to teach one person. you are able to do it remotely, and you are able to do it concurrently on a concurrent basis. And the next important thing that we're also working with Huawei is that, as you can tell just now, we have lots of data. And we have also put in place lots of condition monitoring. Now, how are we going to use all of this data, organize it in the most coherent manner, and such that this data can learn? Because if you are able to put outcomes to patterns of data, the machine is able to learn, and of course they are smarter than us. They're able to then tell you that if these conditions and parameters were to happen, I know something is happening, I don't know what it is, but it will result in some undesired outcomes. And if the machine is smart enough to tell us as an operator upfront, that may give us very precious seconds and minutes for us to intervene. So I think these are two of the projects that we are working with Huawei as our strategic technology solution provider. And we hope to share with you more next time, perhaps at InnoTrans, on some of the new technologies that we incorporate. But I do welcome you, I do invite you to come and visit us in Singapore, and we're more than glad to work with you. And hopefully by then I will be able to share with you that we don't only just operate in Singapore and Auckland, we are in Sydney, we're in Paris, and we're in Stockholm. Thank you very much for your time.
Thank you, Mr. Sim. Very impressive digitalization achievements. Now, with several years of experience in leading the digital transformation in different industries, and in particular in the rail industry, Huawei is the train taking us towards the data-driven digital smart era. So let's hear now how Huawei's cutting-edge technologies can be harnessed to provide innovative applications for the rail industry. Therefore, please welcome with me on stage Mr. Stephen Chong, the CTO of rail industry in Huawei EBG Aviation and Rail BU.
It's very great to see here so many old friends and also some new friends in this summit in Berlin. So I remember in InnoTrans 2018, we proposed the cloud-based rail industry. Since then, Huawei has committed to propose our platform, our solution based on the cloud technology. After years of hard work and practice, we have successfully deployed, released some, I think, solutions for railway digitalization. So today, I would like to take this responsibility to share all this kind of solution and experience with you together. Let's say after industrial and electric and information eras, so the railway industry has come into the smart era. So compared with the previous eras, so the underneath data will become more valuable. And in future, after the data sharing, and then the whole digitalization, the whole rail industry will come into the future digitalization and moving forward to the smarter mobility as a service. Shenzhen Metro actually is our strategy customers in digitalization. We have signed a strategic cooperation agreement in October 2018. We also started building a cloud platform in Line 6 and Line 10. We also deployed some, I think, key projects with Shenzhen Metro. For example, such as the Futian Smart Hub and our IOC and our CDMC and so on, this kind of project. And based on this kind of project, Huawei has understood and future digitalization should be gradual, and we should, I think, go, I think, look forward step by step. We have released a series of solutions regarding this digitalization, such as the the IOC, the smart construction, and so on. Shenzhen Metro believe the future digitalization is to achieve 5-1 goals to realize the future digitalization. The 5-1 means is security one network, the construction one map, and the operation one table, service one process, and the management one dashroom. Let's take example, management one dashboard. So that means it's we put, I think, we almost put more than 2,000 KPI items in a big screen. There is a big screen in the control center of Shenzhen Metro. So we put all these items on this big screen. So that means we use this kind of technology and the solution to collect all the data from all the applications. And our digital platform can centrally, I think, plan and deploy our, I think, ICT resource based on demand allocation and efficiency sharing and so on, these kind of issues. So I think in your future digitalization, Huawei can use this kind of cloud platform technology and some smart solution to enable the railway industry more smarter and more efficiency. How we understood that digitalization should be gradual. So there are some, I think, different steps for the digitalization. In the traditional line-based operation, some new technology also can be provided for this stage. So to improve the bandwidth performance and such as some, I think, Wi-Fi 6 and or I think optic transmission network and so on. This kind of technology can be proposed in this stage. Once in the future, once the condition is ready, we can deploy the cloud-based technology to run network-based operation. And we also can deploy some smart rail to provide smart operation. And finally, we can realize the real mobility and realize the mass as a service in future. While we sums up our experience from digitalization into methodology 1, 2, 3, 4, 5. So 1 means we should, it's one target. We should target to the mass. This means the mobility as a service. 2 means 2 digitals. We should consider the digital infrastructure, digital business flow, and these 2 digits should be the foundation of the future digitalization. 3 means 3 service flow. So we should optimize the business flow, including along with, I think, the passenger, the vehicle, and the goods. And we should consider this kind of the whole, I think, business flow to cover by digitalization technology. The 4 means it's 4 domain, and means which our solution should consider the whole life cycle, including planning, construction, operation, and maintenance, and so on. 5 means it's 5 technologies, including our AI, cloud, big data, this kind of technology together. So through the methodology 1, 2, 3, 4, 5, that means we can enable the future railway industry and our society and the economy more smart and benefit from this kind of digitalization. How we define the full service architecture based on device connections and the unified platform. So in the bottom connectivity, so we can provide a lot of connectivities that we propose that maybe you can see in our booth. For example, the FRMCS, Wi-Fi 6, and this kind of technology. We also can, you can see now, all optic network, compact network, and so on, this kind of solution we propose in our booth. So in the middle is a digital platform. So in this layer, we combine the ICT resource and the data and together, and based on, I think, amount allocation and provide some smart service for applications. In the upper layer is regarding actually is applications. So in the urban real avenue, so in the real way, we can provide a lot of, I think, applications. So what we have done is we optimize this kind of applications based on our AI algorithm and some, I think, is big data technology to improve the efficiency for this kind of applications. And the very important thing is one is regarding the intelligent, which is integrated sometimes, operation center. So what we have done is we just mentioned is we can provide, we can integrate all the ICT resource and the data into this big screen to provide, and I think, the whole picture for the management, just in order to how to say, for the construction, to make a decision and coordination and so on. So what we propose for the industry is the very important action should be done if you want to do digitalization. Let's reshape the connections, reconstruct the platform, and enable intelligence. So once you want to do digitalization, you should consider this kind of actions before. Let's make, I think, some example from China. So we have done a lot of projects in China metros. So this kind of project actually may cover the application for construction, for operation, and for maintenance also. So let's take an example from the operation and the maintenance part. We has used one combined technology of 5G, video, and 5 and big data to upload the real-time, how to say, it's a high definitive camera picture from track site, and detect the usage of pantograph, detect the status of the rears, and sometimes we can detect the deformation of the tracks and so on. So it looks like one kind of predictive maintenance, real-time to certain extent and so on. So this kind of application and innovation can improve the efficiency of the maintenance and also save your labor cost and so on, and ensure the operation and the maintenance safety and so on, this kind of thing. We also, actually, we have successfully deployed our cloud platform in Shenzhen Metro and in Huawei Metro. So we use, just to mention, is digital platform to centralize all the ICT resource and data by cloud technology and big data technology. So all the data will come into one data center, virtualized in its data center. So the practice from this solution is proven that we can save more than 50% IT resource utilization. And we also can improve and reduce ICT total cost for the construction and so on by 50% also. As you know, the connection is very important capability for Huawei. Huawei almost can provide the whole some, I think, technology in connectivity part. Our full connected real system can not only support the transmission from the track side, from the train to station, but also we can provide some backbone network, compact network to transmit all the terminals and the data from different locations and applications. Here we have proposed some, we have listed some, I think, solution we focused on, and we should, I think, develop in next maybe years we in the market. we see it's smart 300G and LTM, FRMCS, Wi-Fi 6, and so on, this kind of technology. We just mentioned a lot of digitalization have done from Shenzhen Metro. So the digitalization in Shenzhen Metro is not, I think, realized in one step. We have done step by step. A lot of new technology has been delivered in this customer. And for example, there are OTN. We deploy the OTN network. Just not only improve the bandwidth, but also want to try to transmit the data to the cloud platform. We also for the Wi-Fi 6 and the 5G and the cloud platform and so on. This kind of technology is deployed in this customer to improve and to upload some smart application and for operation and maintenance and so on. Let's say some, I think, project from overseas market. So this is one, I think, use case in Istanbul metro of Turkey. So we use Wi-Fi train-to-ground communication system to transmit all real-time onboard service to control center. So this project we have deployed in UUC line, and almost is 16 HD camera picture, and the piece, this kind of service has been transmitted from train to station and then to the control center. In the future, we also want to update this kind of solution to Wi-Fi 6 train G solution. So in this solution, the bandwidth will upgrade to 1.4 Gbps at the speed of 160 km per hour. And the latency time is less than 30 milliseconds. So based on this solution, you may see almost all onboard service, I mean the real time can be transmitted real time to the station and to the control center and so on. Of course, for our Wi-Fi 6 solution, currently we only propose to transmit non-critical onboard service to the station, from train to the station and then to the control center. I just mentioned that we have some, I think it's very smart solution. We see it's smart 300 Gbps. So this solution proposed is only to meet the requirement of all the application data from the station to the platform. And also we want to meet the requirement for the TOD, commercial TOD in station and in control center, maybe sometimes along the track side. And also we want to try to use this solution to meet the requirements for some traditional application. Just some, for example, some systems need 2 Mbps, this kind of bandwidth and the interface to transmit some information to station and to control center. So we combine this kind of requirements together and propose this solution. We can use 1 fiber and 2 plans to transmit this kind of application and service to the control center and so on. Very important thing I want to mention here is we are ready to, we have one feature is one drop to cloud. We are ready to transmit all the data and the application, whatever from the station or from track site, from depot to our control center in the digital platform. Here we have one page is I want to mention about our FRMCS. And later, our president of Huawei EBG, various product will release our Huawei FRMCS solution. Only one thing I want to mention here before it's with the higher security and 5-line reliability and 100 megabps bandwidth. So this kind of solution we see the Huawei FRMCS solution can not only transmit all the traditional service, like for example, signaling control, voice communication, to cover more, I think, use area defined by UIC FRMCS. For example, some real-time, non-critical real-time video communication, and some rapid perception and some smart infrastructure and so on. This kind of application and data can be transmitted by our FRMCS solution directly. Huawei is, I think, is a global ICT infrastructure solution provider. So currently, we have provided our solution and service for more than for more than 300 lines of urban rail, and also cover 130,000 kilometers of railway. So in the future, I think from Huawei, we will focus on real digitalization and contribute more, I think, solution and experience from Huawei side. And in the future, we will cooperate with our partner, and we will rely on our strategy of platform and the ecosystem to serve, I think, better the real industry. Okay, so this is my presentation. I hope we can work together to create a new value for real industry. So thanks for your time.
Thank you, Mr. Chong. Now, to complement the leading Huawei technologies, let's hear now from our partner, Almaviva, on how modern ICT makes railway infrastructure smarter. So please welcome with me on stage Mr. Vincenzo Bloise, the International Sales Director at Almaviva, and Mrs. Flavia Franchini, Solution Expert for Global Monitoring.
Good evening, and thank you very much to Huawei for the possibility to participate here, and to all of you for the attention. Well, it's nice after the presentation that you have seen to speak about application and solution. Almaviva is on this side. Almaviva is an ICT solution provider working since more than 25 years in transportation, as you will see now. And so it will be nice to have also this aspect joined to all the aspects that we have seen before in the interesting presentation so far. We decided to have, with my colleague Flavia, a two-voice presentation here. First of all, I would like to introduce you the Almaviva Group. Our company is a company that has the headquarters in Italy, but is spread all over the world. This you see some numbers of our company. So it's a big ICT solution provider, and we are expanding in the world outside Italy, outside Europe, and working in many other countries, as you can see. If you please can go on with the slide. Thank you. These are the sector where Almaviva is working, and one of our characteristics is to have a long-term relationship with clients. Usually when you start to collaborate with the clients, it's not only for one project, but we become a long-term partner for a client. You can see there some of the clients that we have, all important names. And then those are the segment where we are working: government segment, financial service, industry, telco. But one important, very important segment for us is transportation. Transportation is 27% of our revenues, and we have just make a focus on the transportation field. We have over 1,000, I can say today, over 1,200 people working only to design, develop, support, operate transportation solution and application, covering all the process of the transportation world. You will see later when Flavia will speak about our platform. We branded this platform, we call it MUVA. And this is resuming all our offering in the transportation world, which is quite wide due to our experience. We have born in the rail segment, but today we work in many other segments of the transportation world, bringing our experience in other segments. Because we are big, we have several competence centers, we have demo labs, we have some peculiar company also engineering some products. For example, we are engineering some product that goes on the train, and they are certified to go on the train. We recently won, and is one of the brand that you see there, a very important tender for Washington Metro, and we are going to provide to Washington Metro all the passenger information system, hardware, software, firmware, that will provide the passenger information system service to the Washington commuters, to the Washington passengers. We are, as I said before, working in several segments. So we are working in seamless mobility. What we intend for that, we intend all the smart city solution from the mobility point of view. You know how much the mobility is becoming a multimodal world. Is not, and passenger wants more and more end-to-end solution from the service point of view, which is not only a journey planner. Everybody of us, I think, are using journey planner, but is more, is services, is ticketing, and is going towards MaaS, mobility as a service, which is the new keywords in the market. Well, actually, we are working and we have solution for MaaS, despite the fact that the mobility as a service is not at the moment well defined as a landscape, but we are, putting our solution and our different components, module software components, in a MaaS suite to propose to our client. Rail is the segment that we are born, and we have lots of solutions. You see here also some important names for the construction point of view, train builders, Alstom, Hitachi, CAF, etc. And we are working with all of them, digitalizing the train, digitalizing the asset, okay? We entered into the roads segment a few years ago, but we already do quite important things on the road segment. For the terminal hubs, it's important. We will have a focus today about the terminal hubs. For us, the hubs is a concept where there are passengers or freight moving in a certain area. So for us, hub is a train station, is a bus station, is a port, is an airport. So that's the concept of the hub. And we have solution for the hubs, okay? And the intermodal logistics for the freight solution. So this is the segment of the transportation market where we are working. Now to get into more deeply where we are going to the solution, I leave the floor to my colleague Flavia.
Good evening to all. In this slide, we can consider the digital transformation and all technologies, emerging technologies that enable digital platform and new deploy model. Blockchain, IoT, 5G, AI. Without modern architecture and an organization, an adaptive organization that permits to involve people to deep and to use this kind of technology. We don't have digital platform and a scalable solution, performance solution with the possibility to integrate in this digital platform all technology and the environment, technological environment. This is a way to introduce the importance of this technology and the skill and the organization that permit, that enable a digital platform that we can see in this slide. Our solution, that it is MUVA, and identify 5 lines that cover all the environment, all the public and private sector of transport. For example, first of all, the line about customer-centric mobility, that is for people. The second one, traffic and transport, that is related to transport, traffic management, transport management. The digital, the line, the central line is the line that that enable the other line for digital, transport digitalization, asset, smart train and vehicle, smart station. And asset management and intermodal logistics. This line identify and in information hub that permit to collect all data and all function and integrate the different line and to realize a control room that permit the representation of this kind of information and data.
I would like just, thank you Flavia, to integrate this to say that this is a complete suite for the transportation world, as I said before, so it's serving all the processes there, operation, maintenance, customer service. But one of the things I want to emphasize more is the asset digitalization, so the central line. As Flavia said, asset digitalization is an enabler for making services, to develop services. It was very interesting to see the presentation by Singapore that have a lot of emphasis on this, on the fact that technology is enabling also the quality of the service. And not only the technology, obviously, all the processes, and I find very interesting the presentation. But again, first of all, if we are going to digitalize, and we're doing that, together with Huawei, obviously, which is the expert on the infrastructure, and we like the partnership for that, because we are complementary from the application point of view, from the infrastructure point of view. And so to digitalize asset is the base to develop more quality service, more quality application, and in the end, a better services for client and a better management for the companies. So I want to emphasize this, which is the future, on our opinion, of the future development in the service and the applications.
In this slide, we have global monitoring. We introduced global monitoring because, as we said, technology and digital platform permit to facilitate the transport and the usability of these important tools. In this picture, we can see roads and railways that are the most important application and environment and infrastructure in which MUVA and his platform can permit to introduce. Structure as bridge, dams, viaducts, tunnel, terminal hub, in particular terminal hub, are the point in which people can live in a way more easier. This global monitoring is permitted by a lot of competencies and skill that plant engineer, transporter, computer scientist can contribute and can apport digital transformation and value. In this picture, in this chart, we have represented an application of our solution, in particular the different layer from the field layer in which there are sensoristics and gateway, and thanks to the multi-network channel, we can enrich, we can gain a lot of data, and the edge layer that permit to elaborate and to, thanks to the 5G technology, aggregate and simulate a lot of algorithms that permit to bring in control room where there is users and operators all the only the data that are important to monitor and to historicize. Situation room is on top of this chart, and as we said, information hub permits to integrate all the data. The support services are very important and permit to transform this data in information. As we said, this is the chain, the value chain that permit to enable and with the data enriched by sensoristics in the field, thanks to the connectivity, for example, with our partnership with Huawei. Is possible to, thanks to cybersecurity and IoT sensoristics about for example, smart hub or infrastructure, elaborate this data and use a lot of algorithms relating to that permit interpretation and information generation, and report all this data in a control room. There are a lot of processes that are impacted in this asset digitalization. Planning, investment, design, infrastructure are the vertical business asset that have a challenging goal in this digitalization. We have said about real-time monitoring and diagnostic in, for example, structural health monitoring, and use algorithm to predict maintenance, and also in the road, in the environment of road, safety traffic management.
Okay, thank you, Flavia. We are now making a particular case of this, what just my colleague says about the stations, the train stations. Okay, Terminal Hub, as I said before, for us is a general concept. but we are developing, we already develop, we already deliver, I can say, in many cases, in Italy and around the world, a new concept of stations, a new concept for services, for infrastructure in the station that enable a new generation of the station. For example, we are just mentioning here some of the things that we are doing. Passenger information system, very complete, very reliable. We are now just delivering a new project in Finland where we equip with our solution all the passenger information in all the train stations in Finland. And smart energy management, for example, because we are able to automatically trigger the consumption of the energy in a station depending on the flow of the people, of the presence of the people, of the hours of the day. So, for example, we are now already connecting and deciding how to use the energy and the lightning, for example, of the station, depending on the number of passengers that are there. And for example, in the small train station, we are able, because we are detecting how many passengers are there, for example, to decrease the lights automatically if there are no passengers in a small station, for example, to save energy, and all things like that. Structural health monitoring is very important because make us understand and make our client understand 2 points of view, the maintenance point of view and the operation point of view. So to monitor the structural health is helping two processes, maintenance and operation. Smart video surveillances for security and other purposes, obviously. And also, we have a very interesting solution for what we call smart equipment management. So remotely, today, we are managing, for Italian Railways Group, more than 300 stations with all the equipment of the station remotely. But it's not only a question of monitoring, we are controlling. So for example, at 200-kilometer distances, we can test if the lift is working, if an escalator is working, if the lights are working, we can open a gate. Smart equipment management is a very powerful solution that is able to save a lot of time, a lot of money, and also to increase the service level. Okay, so those are the solutions that in a new concept of smart station we can implement. So basically, to resume the distinctive elements of our solutions. So we develop end-to-end solution for clients, covering all the aspects from the technology to the service, with a particular attention to the goal that the business has in mind. Always thinking that the technology is not by itself, but is going to serve the business and their needs. We can manage different type of signals coming from the different sensors and equipment on the field, and have one overall view. You have seen in the MOVA platform, there is the concept of control room, of operation control room, and we can do that. We have a lot of experience at different levels. We have a know-how with our platform that we can spread over, and we have the ability to bring a large-scale technology in a safe and contained time frame, so to have a precise goal also in the time frame of the project, in the time frame of the solution. So this is basically resuming the ability. To conclude our presentation, I will leave again the floor to Flavia to speak better about how our solution fits with Huawei technology, and on the map that you have just seen before, on the Stephen presentation, and to see better how our partnership fits good together. Please, Flavia.
Yes, in fact, in this picture, we can see how Almaviva, with competencies and know-how about the market, the client, the customer, and the environment specific, can enable the technology that Huawei offer. In fact, we can see smart stations, smart vehicle, asset management, predictive maintenance. The topic about the topic that we have introduced in MUVA that are present in platform MUVA, we see in this integration with the Huawei technology and the Huawei infrastructure. This is an ecosystem. This is an ecosystem that enable and facilitate the digital innovation and transformation with important elements that are digital platform, strong installed base and local support, and connectivity, and emerging paradigms of digital mobility. This is a good partnership in which the skill, the competencies, the known of the market and the technology can enable the change.
We thank you very much for your attention.
Thank you.
Thank you, Mr. Bloise and Mrs. Franchini, for taking us through your innovative solutions. As you know, train-to-ground communication is a major pillar of railway operations, and wireless technology is evolving to bring more efficiency, more service capabilities, while securing the transformation of critical services. As a leader of wireless technologies, let's hear now from Huawei how the new FRMCS solution is the path for digital railway innovations. So please welcome with me on stage Mr. Li Jie, President of Huawei Enterprise Wireless Domain.
Good afternoon, ladies and gentlemen. It's 3 years later that I come back to Europe again. It's my honor to stand here to represent Huawei to announce the FRMCS solution. Today, my topic is Huawei FRMCS solution, enabling railway digital transformation. Well, when we talk about wireless technologies in the railway system, GSMR is very famous in the past 30 years. When I talked to my friend, they said, what you did in the railway system? I said, wireless. Oh, GSMR. Oh, yes, GSMR. So that means for the GSM technology, it is quite successful in our railway system. But right now, we meet some problems. The GSM, the life cycle of GSM meets the end of its life cycle. What does that mean? Here is some figures that I'd like to share with all of you. That's from the operators. In the year 2021, nearly all the operators all over the world stopped investing in GSM network. And in this year, nearly 90% of the vendors stopped produce GSM devices, equipment, and components. What does that mean? Maybe in the next 10 years, GSM will not, we can only maintain the GSM devices and equipment, we cannot produce more. So, how about our railway system? Because we use it, we keep using it for nearly 30 years. 30 years. Then, for the next 20 or 30 years, what should we use? So, I think right now it's really the time to enter the broadband era. Our broadband technologies for the wireless system started in the 2012 for the LTE system. And in the year 2019, 5G comes to us. Then, for our railway system, does 4G or 5G is really so important? Yeah, of course it's important. But all of these belongs to broadband technologies. For the wireless technology, I think 4G and 5G, such in the lower band, the difference, the efficiency of the difference between the 4G and 5G is quite small. It's quite small. The 5G technologies will have its benefit with a higher band, with wide bandwidth. For example, 100 megahertz, something like that. But for our railway system, we do not have a so wide bandwidth spectrum to serve, to build our network. Then, that's why Huawei right now trying to develop the FMCS solution, both using 4G and 5G technology together. Okay. And trying to improving the connectivity experience, our broadband train ground wireless enable railway transformation. The first words that I'd like all of you to emphasize, I'd like to emphasize is the robust. Robust, that means we should study what the GSMR solution that successful rate. In the GSMR era, the ETCS and the voice is the major services that we can provide. But these two kind of services it's the most important services for the railway. So when we come to the broadband era, robust broadband wireless solution carry these kind of two services to make it security, to make it stable, and even can carry like a multimedia dispatching and the new ETCS, some kind of service like that. That's very important. It's the first part for the robust. And second, digitalization comes to all kinds of industries. Also comes to our railway system. So there must be a lot of new services that in the future that will come to us. For example, like cabin CCTV, like cabin peace, and also the trackside monitoring. And a lot of more sensors will come to us in the future, like temperature. So how can we transfer these data to our data center? How do we deploy our systems quickly and smoothly? This is the idea for our FMCS system, that to make an agile wireless system that can help us to deploy all the applications quickly and fast. Right now, I think more organizations and areas that they think it is time to enter the broadband era. So FMCS is accelerating now. For example, in China, the government just announced that for 10 megahertz in the spectrum 2.1 gigahertz, 10 megahertz, that it can be deployed in the railway for 5G. And also in Europe, at 1900 megahertz, it's also deployed for the FMCS. And like 3GPP and the UIC, these kind of organizations, accelerating their standard. So our idea about the FMCS with the robust network, agile network, and future-oriented evolution are accepted by all these organizations. So when we using different spectrum for the broadband network, there are also some bottleneck. For example, with the 1900 megahertz compared to 900 megahertz, the coverage is the limitation. The coverage is really the limitation. That means if you have to build a new railway with the same coverage, the same as GSMR, you will maybe build more than 2 times devices, 2 times equipment. Only 2 times equipment cost. I think that we can accept. But if we want to build tower, we should get more acquisition of the tower. That will be very, very difficult for our railways companies. So how can we overcome these difficulties? So in the past 2 years, Huawei recognized this kind of bottleneck for the higher frequency broadband system. So we propose that we will using multi-transmitter and receiver system that to enlarge the coverage of the base station. And the second, we're trying to push the organization like UIC, like 3GPP, to increase the power of the terminal. Because for wireless, all of us know in the broadband era, the terminal's power is the bottleneck for the coverage, for uplink. And fortunately, that this year, all the proposals are accepted by this organization. So I think in the future, for the solution, it is ready to deploy. Then, the next thing that maybe all the companies should concern, it is evolution. GSMR solution lasts for 30 years. Why we cannot produce a GSMR anymore? Just because here maybe it's something professional. Just because GSMR using the single carrier technologies, just because it should not be interferenced by the operators. But for the broadband, we use multi-carrier technologies. The single carrier technology and the multi-carrier technologies, all the hardware are different. So if you are using single carrier technologies, all the hardware and software are customized. And in the future, now it's 4G and 5G. Or maybe 10 years later, it will be 6G. What should we do to help us that can smooth the evolution? So Huawei proposed the first thing is make sure all the hardware should be unified. So right now for Huawei FMS solution, we use the LTE and 5G base station and core network. We use the same hardware, the same platform. Only software upgrade can support from LTE to 5G. And in the future, for the devices, we can develop dual model or triple model to support different networks. That will largely to help the customer to reduce the investment. Okay, here I just want to emphasize three aspects again for Huawei FMS solution. The first thing is robust. Is to make our railway system to be stable, to be secure. The second, our network should be agile. That can help our customers to deploy new services easily. And the third part, that is future-oriented evolution. We use our unified platform and architecture for the future. That means only software upgrade can support from 4G to 5G, or maybe in the future even 6G. Okay. Here is our portfolio and the key features for Huawei FMCS solution. You can see for the powerful RU, it is the most developed RUs in the world for 1900 megahertz spectrum with 8T, 8R. That means compared to right now the 44R, compared to the 2T2R, 88R can increase at least 3 dB gain, coverage gain. That means double coverage compared to 44R. And also for the terminal side, we cooperate with our partners to develop the higher power that reaches to 31 dBm, the cap radio, to support our services. And also for the core networks and the base station, we are using our unified hardwares that can support both 4G and 5G. On the right side, that when we compare to other devices or other solutions, our software customized features here that's to support our FMCS longer evolution. For example, we are using our dual network redundancy architecture. That is a co-site dual wireless layer. Like to make sure that all the signals cannot be lost. It helps us to build a really robust network. And second, we optimized our features that can help us to support more than 300 kilometers per hour high-speed way. Right now, in the operators network, we can see they announced that they can support more than 300 kilometers per hour speed, but always there are drop rate. In China, I have this kind of experience is not so good. It's not so good. But for our railway, drop rates are not allowed. Just because we carry the signaling, the controller services, if there is a dropway, maybe the railway, the train will reduce its speed. So here, we optimized our features to support nearly 300 kilometers per hour, that with no drop rate. Yeah. And finally, we are using the standard interface to help our partners to easily integration with us. For example, here, right now this year, we are doing some tests with our partners for the railway MCX server, like the ETS radio, CAP radio, and some handsets. All these equipment are really have the interface, the IoT test with our FMSS solution. And right now, it works. Here is our cases for the broadband technology usage in the world right now. In China, there's more than 100 metro lines are using our broadband technologies and systems, and it works very well right now. And in the next year, maybe the railway in China and some countries in the Africa and some countries in the Middle East that can using our broadband technologies. Okay, and next, I think I'd like to invite our COO to help to launch the Huawei FRMCS solution.
Thank you, Mr. Li Jie. So yeah, I would like to launch the ceremony of FRMCS solution. We'd like to invite the COO of the COO of Huawei Aviation and Rail BU, Mr. Wang Guyu, Mr. Shangxi, the VP of Huawei Aviation and Rail BU, Mr. Mohammad Fasrawi, VP International Sales, Mr. Li Jie, you're with us here, and Mr. Stephen Chong, the CTO of Rail Industry. And with that, we have arrived at the end of the 9th Huawei Global Rail Summit, in which we saw how we can drive digitalization in future rail while creating new value together. Thank you all for taking the time to attend the summit. And now we would like to welcome you to join us for a drink just outside, followed by the gala dinner that will take place in the Grand Ballroom A, which is next door. So stay safe and see you, and bon appétit.